Okay, let's give you guys some practice. So suppose f is a continuous and differentiable function. If f prime is never zero and a can never be equal to b, then show that f of a can never be equal to f of b. So try to understand what's going on here. So suppose this point here is f of a. If f prime is never zero, so it has to be climbing all the time. Well, so when it's climbing, the gradient can never be zero if it's climbing all the time. So by the time you get to f of b here, let's say f of b here. Well, if a function is always climbing, then you can. It's kind of obvious that f of b can never be equal to f of a. So, or this could be another scenario here. Suppose this point here is f of a here. If f prime is never zero, well, you can have a negative gradient. So if here is, well, if the gradient is always negative, then it's always falling. So by the time you get to, by the time you get to f of b, then you can say that it's kind of obvious that f of b can never be equal to f of a. So well, if f of prime is never zero, well, you could argue that, let's say this here is f of a. You could argue that, okay, let's say it's negative at the moment, negative, and then all of a sudden it switches to positive. So, well, you could argue this, but the thing is, for you to have a gradient of negative, and then all of a sudden a positive, then this here is not really differentiable, because the condition placed on you is that it has to be differentiable and continuous. Okay, so if you have to obey continuous and differentiable, and f prime never being equal to zero, then it's kind of obvious that f of a can never be equal to f of b. But the question is, how do you show this mathematically? Okay, so think about it. It's easy to understand the problem, and it's kind of obvious as well. But showing it mathematically, I think you might have a problem. But have a go anyway. Press pause and have a go. Okay, so to do this here, remember that a can never be equal to b. Okay, so picture this in your mind here: a over here, b over here. A can never be equal to b. So to show this, start with a mean value theorem here. The mean value theorem. This is a mean value theorem. There must exist a value of c somewhere between a and b, where this thing here is equal to this thing here. Okay. This. Hang on. Bear with me. If f prime here. So this here is the mean value theorem here. Okay, so start with this, and then times both sides by this thing here. That will then give you this. Okay, that will then give you this. Now looking at this, okay, looking at this here, you've got one bubble here multiplying with this bubble here. Okay, but if you look at this here, b minus a can never be zero, because b minus a can never be zero because of this bit here. A can never be equal to b. Well, that implies that b minus a can never be zero. So this bubble here can never be zero. Now the other condition was that if f prime is never zero, remember up here. Hang on, bear with me. Up here it's saying that hang on, let me think. Bear with me. What was it? So it's saying, well, the point I'm trying to make is that this can never be equal to zero. This can never be equal to zero, because up here it's saying f prime. If f prime is never zero. Okay, it's never zero. So this thing here can never be zero. This thing here can never be zero. So you can say that, well, non-zero times a non-zero can never be a zero. So the point here is that from here you can make this statement here. This thing can never be equal to 0 because you've got this thing here can never be 0. This thing here is never 0. Therefore, you can make this statement. Okay, so so that would imply that f of b can never be equal to f of a. So here, end of okay. So this here is the final answer.